Seeing the Invisible, Exploring the Infrared Universe with WISE. In visible light, we can see many stars in the sky. But there are things that can't be seen in visible light. Watch what appears when we shift from visible light to infrared vision. On the lower right of the image, we see a colorful cloud of dust appear into view. This is the nebula S175. New stars are forming inside this nebula. The glowing red sphere on the left is Tycho supernova remnant. Tycho supernova remnant is the remains of a star that exploded, sending out a shock wave in the gas and dust between the stars. Here we see the dust that is heated by that shock wave. What is infrared light? In 1800, William Herschel discovered infrared light by accident. When measuring the temperature of the colors of sunlight, Herschel realized that there was an unseen light just beyond the red part of the visible spectrum. This invisible light is called infrared. Infrared light is part of the electromagnetic spectrum. Visible light is just a tiny part of the entire electromagnetic spectrum. Although we can't see them with our eyes, there are other kinds of light, such as radio, microwave, infrared, ultraviolet, X-ray, and gamma rays. This chart shows the relationship between the wavelength of light emitted by an object, how much energy the object has, and how hot it is. Longer wavelengths, such as radio waves, are emitted by objects with cooler temperatures and lower energy. Shorter wavelengths, such as gamma rays, are emitted by objects with hotter temperatures and higher energy. Infrared light is emitted by objects that have less energy and cooler temperatures than objects seen mainly in visible light. There are lots of objects in the universe that emit light at infrared wavelengths, but not all of these objects can be seen in visible light. Using infrared vision allows us to see into and through these objects. The WISE spacecraft saw this cloud of cool dust in infrared light. Infrared light reveals a cluster of newborn stars called AFGL 490 inside the dust. This nebula is about 2,300 light years away. NASA's Wide Field Infrared Survey Explorer, or WISE, is a space-based telescope that surveyed the entire sky in 4 wavelengths of infrared light. These wavelengths are 3.4, 4.6, 12, and 22 microns. A micron is a unit of length equal to 1/1,000,000th of a meter. WISE uses these 4 wavelengths to see different kinds of objects. For example, warm dust emits light at 3.4 and 4.6 micron wavelengths, whereas young stars emit light at 12 and 22 micron wavelengths. WISE launched in December 2009 and completed its primary mission in July 2010. WISE data is being used to find the nearest and coolest stars, the origins of stellar and planetary systems, asteroids, and the most luminous galaxies in the universe. Let's switch from the visible light view of the Sculptor galaxy to WISE's infrared view. All 4 of WISE's detectors were used to create this mosaic of the Sculptor galaxy. The colors represent specific wavelengths of infrared light. Blue represents 3.4 micron light, cyan represents 4.6 microns, green represents 12 microns, and red represents 22 micron light. Each wavelength allows us to see specific features of the galaxy. The galaxy's center is very bright because there are so many stars concentrated in the core. Here we shift from visible light to 3.4 and 4.6 micron light. Blue and cyan show hot stars of all ages found throughout the galaxy. Let's go back to visible light, then shift to 12 micron light, shown in green. Green reveals the Sculptor galaxy's emerging young stars in the core and spiral arms. Lastly, We'll shift back to visible light, then into red, representing 22 micron light. Red reveals the dusty cocoons of infant stars in the galaxy's core. Now let's take a tour of the universe as seen in infrared. The Pleiades are one of the most well-known star clusters. They can be easily seen in visible light in the constellation Taurus. In infrared light, we can see that the star cluster is passing through a cloud of dust. The stars heat the dust, causing it to glow in infrared light. Alpha Cam is a supergiant star. It is also called a runaway star because it is traveling at a speed of 9.4 million miles per hour. If Alpha Cam were a car driving across the United States, it would take less than 1 second to travel from New York City to San Francisco. The red curve is a bow shock of heated gas and dust created by the star's speed. In this image, the bow shock is moving from right to left. Nearby is the spiral galaxy IC 342. It is also called the hidden galaxy because it is hidden behind the Milky Way as seen from our view on Earth. WISE's infrared vision cuts through the Milky Way's band of stars, dust, and gas, allowing us to get a better view of IC 342. Here is another type of galaxy, this time the irregular, small Magellanic Cloud seen in the southern constellation Tucana. In visible light, this galaxy appears to be a wispy cloud. It is named after the Portuguese explorer Ferdinando de Magellan, who observed it in 1519. The two green streaks seen in the upper half of the image are satellites orbiting Earth, which happened to pass in front of the small Magellanic Cloud when WISE captured this view. Moving to the northern constellation Cassiopeia, WISE's infrared detectors reveal the Heart and Soul Nebula. Located about 6,000 light-years from Earth, these clouds of gas and dust are part of a vast star-forming complex in our Milky Way galaxy. Similar to imagining pictures in clouds, nebulae are sometimes named after what someone thinks they look like, in this case, a heart. Can you see the shape of a heart in this nebula? The next object is a planetary nebula called NGC 1514, located in the constellation Taurus. It is actually a pair of stars. One is a dying giant star that is puffing off its outer layers of material to form a large bubble. The second star is a white dwarf that is sending out jets of material that smash into the bubble, causing the orange rings we see here. Gripped in the claw of the constellation Scorpius sits the reflection nebula DG 129. It is called a reflection nebula because it reflects light from nearby stars. Some people see this nebula as an arm and a hand emerging from the cosmos. If you picture the thumb and forefinger making a circle, it is as though you are seeing a celestial OK sign. The bright star on the right is Pi Scorpii, one of the claws of the scorpion. Although unremarkable in visible light, in infrared light, some might see this next object as a blood-red jellyfish in a forest of seaweed, a big red eye, or a pair of lips. In fact, it's a sphere blown out from a humongous star called V385 Carinae. The white dot in the center of the sphere is a star that is 35 times more massive than our Sun. Because it is so big and hot, it lives fast and dies young. Coming back into our solar system, this is a mosaic of WISE images showing an asteroid tracking its way across the sky. WISE observed this small rocky body at different points in its orbit around the Sun. This asteroid reflects only a few % of the visible light that falls on it, but is clearly seen in infrared light. Finally, let's end with another solar system object, this time the comet 65P Gunn. Comets are balls of dust and ice left over from the formation of the solar system. Here we see the nucleus of the comet in the center image. with its long tail trailing off to the right. Just ahead of the comet, on the left side of the image, is a debris trail from the comet's last orbit around the Sun. Dust in the debris trail is warmed by sunlight and glows in infrared light. This worldwide telescope tour was created by the WISE Education and Public Outreach team at the University of California, Berkeley's Center for Science Education at the Space Sciences Lab. Special thanks goes to Ned Wright, Peter Eisenhart, and Robert Hurt. For more information about WISE, please visit the WISE website online at wise.ssl.berkeley.edu.